Hey everybody, in this AP Chem series video, we're going to take a look at the difference between something called intermolecular and intramolecular forces. First, remember that we've already studied lots of different attractive forces that exist in the chemical world, like the attraction between electrons and the nucleus that holds an atom together in the first place, or the attraction between cations and anions in ionic substances, or even the attraction between the nucleus and shared electrons in a covalent bond. In this video, we're going to take a complete look at all of these attractive forces that hold atoms together and classify them properly. To begin the classification process, we first have to know that there's two broad categories of attractive forces in chemistry, intermolecular and intramolecular. The intramolecular forces, those are the ones that hold atoms together within a molecule. And even though that word molecular is in the title of this attractive force, we sometimes use this to describe substances that actually aren't made of molecules at all. These forces tend to be much stronger and are usually simply called chemical bonds. The other type of attraction, the intermolecular forces, are weaker attractions that occur between separate molecules. So if you imagine a molecule A and a molecule B and what might cause them to be attracted to each other, then you're talking about intermolecular forces. Here's a model that might help you understand the difference between these two terms. We've got three molecules of hydrogen chloride drawn out here. If you looked at the attractive force that holds the hydrogen atom to the chlorine atom within one single molecule, you'd be talking about an intramolecular force. You might have also noticed the red dotted line connecting these two separate HCl molecules. That's trying to show that those two molecules are also attracted to each other. And since that attraction is occurring between two separate molecules instead of within one single molecule, that would be an intermolecular force. These are some of the key ideas for this video. Make sure you take some time and write them down. So now let's focus in just on the intramolecular forces and generate an official list of all the ones you'll see, and we'll also rank them roughly by strength. Now this is kind of tough to do because there's no clear-cut guidelines here for which of them are strongest and which are weakest, because they can vary widely in terms of their strength. Despite the fact that they can vary widely, you will often see ionic bonds being listed as one of the stronger types of intramolecular forces or chemical bonds. Ionic bonds, of course, are the attractions between cations and anions. At number 2, we'll have covalent bonds, the attractions between shared electrons in two separate nuclei. And in last place, metallic bonds, the attraction between delocalized electrons and the metal cations in the sample. That list makes up some more of the key ideas for this video. Make sure you take a moment and write them all down. And finally, let's do the same thing and make an official list of the intermolecular forces that you'll typically see in AP Chemistry. We'll rank these by strength as well, and while there's lots of variation, there are some more well-recognized patterns in terms of which intermolecular forces are stronger or weaker. At the top of the list and taking the position for our strongest intermolecular force is something called an ion dipole force. That's the attraction between an ion, like the Na plus cation shown here, and polar molecules, like the polar water molecules surrounding it. Next, strongest, we've got hydrogen bonds. Hydrogen bonds are actually a subcategory of another type of intermolecular force called a dipole force that we'll see in a little bit. Hydrogen bonds are a dipole force that get their own special title because these are attractions between very special types of extremely polar molecules. When water molecules attach to each other, it's a good example of hydrogen bonding. Next, we've got dipole forces. This is used to describe the attraction between any set of polar molecules, like the hydrogen chloride molecules we saw at the start of the video. There's also a strange type of attraction called dipole-induced dipole. These are the attractions between polar and nonpolar molecules, like the water that's polar and the xenon atom that's nonpolar, shown here. And lastly, we've got London dispersion forces. At the bottom of our list, that means these are generally weaker than the rest, although there are scenarios where they can actually be quite strong. These forces are a special type of attraction that all molecules will experience, all particles for that matter, regardless of being polar or nonpolar. And that's our official list of intermolecular forces. Make sure to take some time and write these down. We'll be exploring them in great detail in the subsequent videos. That also wraps up this video. Thanks a lot for watching, and here's a brief summary.